Section 4.3 is showing triangles congruent by angle side angle or angle angle side. The first one we're going to use is postulate 4.3, which is called angle side angle postulate. If you have two angles and the included side of one triangle congruent to two angles and the included side of another triangle, we can conclude that those triangles are congruent. So remember when we did side angle side, the angle had to be in between. Now we're doing angle side angle, so the side has to be in between the two angles that we have. Let's look at our first example. Which two triangles are congruent by angle side angle? So on this first one I see I have an angle side angle. The second one I see I have an angle side angle. On the third one though I see angle angle and then side. So this side would have to be over here in between these two angles in order for me to say I can use angle side angle. So therefore I would say the first two triangles, triangle UVS and triangle EON. And it's important that when you write out your congruency statement that you're again matching up those corresponding parts. So make sure U and E match and then V and O match. So then my explanation was because I had two pairs of congruent side or two pairs of congruent angles and the included side is congruent. I need you to pause the video and try the got it question. On the got it question it asks which two triangles are congruent by angle side angle. So on the first one I see angle side angle. The second one I see side angle angle. So this does not go in between my two angles that are congruent. The third one I see angle side angle. So your first and your third triangles would be the ones that would be congruent. Now I need to write my congruency statement where I match up my corresponding parts. So G has one arc, so it's going to correspond to C, so that's why I put those first. H has two arcs, so that's why it's going to correspond to A, and then last would be O and T. So my explanation was because I have two pairs of congruent angles, and then the included side is congruent. The other postulate that we're going to use is angle angle side. And so this would be where if I have two angles and a non-included side, which you kind of saw in the previous examples, if those are congruent to two angles and the corresponding non-included side, then those triangles are congruent. So pay attention that this key word here, make sure that it's corresponding. So making sure that if I were to lay these on top of each other, that this one would match up with this one over here. Let's look at our first proof here. So they tell me that I have M congruent to K, and they tell me that I have WM parallel to RK. You can kind of see from the marks that I already had what I could lead towards, but your first step would be thinking about stuff that I would have. So from my picture, automatically I see this line in between them, so that means it's going to be congruent to itself, so I would want to mark it as congruent by reflexive. And then when anytime they're giving you parallel lines, they're trying to hint you towards alternate interior, alternate exterior, corresponding same side interior. So anytime they give me parallel lines, I'm going to be looking for those. So think about this and this as my parallel lines, and then WR is the transversal. When I do that, I see that this angle is congruent to this angle over here, and so I then can set up that I would have angle, angle, side to prove that my triangles are congruent. So what I can do is, just like on the previous proofs, we start by writing out what we think it is, so we do angle, angle, side along the side. And then I write down one of the angles I know is congruent. So I'm just going to write that M and K are congruent because it was given. I'm also going to go ahead and squeeze in that my lines were parallel because that doesn't really fit for the next pieces. So I'm just going to go ahead and put it on that same line. Then I need another angle that's congruent. So I can see that this angle and this angle are congruent. Now I can't just call them W and R because that represents too many angles. So I would say it as MWR is congruent to KRW, and that again was because they were alternate interior angles theorem. Then I need a side that's congruent, and we said that WR is congruent to WR because of the reflexive property. And so then I can finish by saying my two triangles are congruent by the angle-angle side theorem. So when you're setting up your proofs, you want to go to your picture and try and find the things that you know to fit angle-angle side, angle side angle, side side side, side angle side. So make sure you're fitting it and then putting it along the side so that you can set it up. Okay, couple more examples here. This one is asking to determine if I know these triangles are congruent. So I'm using the diagram at the right, and it says which of the following statements best represents the answer and justifies the question, are those two triangles congruent? So when I look at this, I see I have this angle congruent to U, and I have I congruent to T. I do have one side that is congruent. However, it doesn't appear to be the corresponding side. So FB has to be congruent to OU, or OT has to be congruent to FI. So since I don't have either of those, this is going to be an answer of they can't be congruent because I didn't have my sides being corresponding to each other. You're going to pause the video and see if you can determine the got it question. So in the got it question, it asks, are those triangles congruent? So what I see is I have a side congruent and I have one angle congruent. I also see an X shape as soon as I look at the picture, so that's indicating vertical angles right here in the middle. So now I can say yes, those are going to be congruent by angle, angle, side, because I have PR congruent to RS, angle A congruent to I, and then PRA congruent to IRS by vertical angles theorem. So 4.3 is dealing with angle, angle, side, and then angle, side, angle. You now have the 4 congruency postulates/theorems that you can use to determine if triangles are congruent, and we'll learn a little bit more with them when we continue on.